So here you can see that a resistance is connected in series with this Zener diode, and one load resistance is there, that is your RL part. Now in the first case we are varying the input voltage. There will be two cases when we are having Zener diode as voltage regulator. The first one will be varying your input voltage and the second one will be varying your load resistance value. Now when I am starting the simulation, so you can see when the Zener voltage is set to 10 volts. So you can also decrease or increase this. Suppose I am doing it to 12. When I am having a lesser voltage value, that is 4.80 volts, the resistance is 1 kilo ohm, it is 50 kilo ohm. Suppose I am doing it to 1 kilo ohm also for simplicity. When both the resistance are 1 kilo ohm, you will be having 2 kilo ohm resistance connected in series and your voltage is 4.8. So since the Zener diode is in reverse bias condition, it will be acting as a open circuit. Now what will be your voltage across this resistance? It will be the half of the applied one. So the applied one is 4.8 and you are getting 2.40 volts because your diode is in off state. And when we increase the input voltage beyond the breakdown voltage, suppose it is 15 volts and the breakdown voltage is 12. Now the voltage drop across this resistance since we are using the same resistance, so it will not be affected much and you will be having the 50% voltage drop across this resistance. But when we are increasing it beyond this value, you will see there will be slight change in the voltmeter across this voltage, across this resistance. But for some reasons you need to have the input and lower resistance value different. So again, starting with 16, suppose I am giving 16 voltage in this case, so you are receiving 10.7. But when we are increasing to 18, it is 12, 21, 12.3, 25, 12.5, 29, 30, 12.7. Means there will be slight increase in the load voltage value when we are increasing the input voltage. That's why it is known as the voltage regulator. After breakdown, I am increasing the voltages, and for all the voltages range, it is showing value nearly to the 12 point something, 12.1 or 12.2, like that. One interesting thing is when we vary this load resistance value also. Suppose I am doing this to 20 kilo ohm. Then you can see the voltage drop across it is 12.4. When it is 200, it is again 12.4. It is 2000. It is 12.5. If I am doing it 20,000, it is again 12.5. Means whatever be your load resistance value, it is not affecting your output voltage, that is voltage across your load resistance. So this output voltage is dependent on your Zener breakdown voltage, that is of 12 volts in this case. So for your observation table,